Okay guys, so this is following on from the last video where we looked at the hermetic wiper sample and the actual wiper settings. In this one, what we're going to be looking at is the actual propagation side of it as well, okay? The sort of process I go through here can be applied to both the wizard side of this and the wiper side as well. It's entirely up to you. For the sake of, depending on your malware, you may have the propagation is a separate component that has the actual dropper inside, which has all your infection and covert stuff, like hermetic wiper is built as, okay? So this is only one side of the actual propagation. There are two major DLL components within hermetic wiper. We'll only be looking at one just for the sake of simplicity, okay? This one here primarily looks at the SMB block and the actual sort of a more traditional way of using a worm-like component compared to the WMI way, which is in the other sample DLL that you can find on something like Malware Bazaar. Okay, so we have a DLL, and when you are debugging DLLs, it is a little bit more complex to work with due to they don't run, as you guys know, by themselves. Okay, so to do so, we need to know a couple things about our DLL that are very brief, and we can actually work with them. Okay. So the first thing I would all recommend you guys do if you're dealing with DLLs is go into PE Studio, okay, and open that up. What I would do is, first thing is take your DLL of any of your malware and whack it in there, okay? The main thing, where you can find all the other data and so on and so forth, a big one to worry about for now is the 32-bit CPU structure that it follows, meaning we will be using x32 DBG, not x64. There is no major difference between the two besides one handles 64-bit based files, one handles 32-bit based ones. Okay, what we're primarily looking at is trying to understand what the components are of this DLL to be passed through and run within the debugger, or if you're going to run it directly as is and look for it through Proc1 Process Explorer, the same sort of stuff applies, okay? So, whilst this is waiting on to go on for it, the big thing I'll bring up is if you're looking at running DLLs directly, what you want to do is you want to use command prompt and run it through the run dll32.exe, okay? So if you get it up like this, what you want to do is you want to do run dll32.exe, like that, and then what you want to do is you want to give your arguments for it. So depending on where your DLL is, you may have to specify the whole path, like so. So C, we're in the users, IE user for this account, then we go to, we're on desktop, and then we go hw.dll, or whatever you've named your one as, okay? Now, if we run this like this, what will typically happen is it will start executing the DLL directly, and the DLL will do what it's supposed to do, okay? One of the core things you need to focus on, though, is sometimes the DLL needs a certain argument to pass through it, which is its exports, okay? So if we come back into PE Studio, we can see the exports are finished. In this example, Hermetic Wizard has 3 major exports it uses, okay? And it's flagged the register server and unregistered server with us, okay? The main focus, what I would suggest for you guys, if you've got multiple exports within your DLL, most malware does not have too many exports, okay? Loads of imports, most definitely. Focus on whatever index one is. So in this case, DLL install, okay? Remember this because we'll come back to it when we load it into our debugger, okay? So if you want to also run it, what you may want to do is do this command, comma, DLL, and then install like so. We run that, we can run the actual malware itself, okay? But for now, we're done with it at this point. So our next stage is, what we want to do is we actually want to look at this through a debugging lens, okay? So we've got PE Studio up. We know that it's DLL install. So this is all lowercase L's and then an uppercase I. Remember that because it's case sensitive for the debugging side. What you have to do is firstly go to x32 And what we are going to do is we're actually going to set up our debugger properly, okay? So to do so, you want to go to File, Open, and then what you want to do is, if you're in the blank one, you want to go to Windows, like so. You want to look for either, if you're in 32-bit mode, System32 or Syswell64. And you're looking for Run DLL32, okay? Because this is an exe, if we load it up, it will load up everything fine within our actual debugger, okay? We're going to use this as the latching point, so our DLL can actually go in with this and run through our debugger directly, okay? Next thing you want to do to make sure, go to Options, Preferences, and in this point here, the more you tick, the more it will load stuff for you, and you can breakpoint at certain points. By default, you'll pretty much have system breakpoint, entry breakpoint, user TLS callbacks, and system TLS callbacks, okay? For simplicity, what we want to look for is system breakpoint and then user DLL entry, as this is going to be our point where we actually add our own DLL, not a preloaded one through Windows operating system, okay? So you save that. And sometimes it's best if you just do Control F2, it refreshes everything with those preferences saved on as such, okay? Now what we want to do is apply the actual DLL directly into our debugger alongside Run32. To do so, we go File, Change Command Line, okay? I've already did it here, but the command I showed you within the CMD prompt, you want to paste here. By default, this will already be in place. You just have to add this as well, okay? As you see, it's DLL, lowercase l's, install. Ensure, guys, that this is the exact spelling and the exact lowercase uppercase, otherwise the debugger won't be able to find it, okay? Also, I know, for instance, a Hermetic Wizard's DLL is usually just the hash of the file in most samples. Change the name to something meaningful and easy to do, okay? So once that's all set there, what we want to do is, if I go into symbols now, we can see a bunch of DLL stuff already in place with our Run32 DLL, okay? By default, it will start at ntdll.dll. This needs to change up here in order for us to actually view the Hermetic Wizard DLL, okay? So all we're going to do is just do Run or F9 if you want shortcuts once, okay? What you'll see is it's now changed to HWDLL, which is our Hermetic Wizard DLL, and it's gone straight to the address of entry point of the DLL itself, okay? This is very, very important. We can now, this means, if you see this screen, guys, it means your DLL has loaded with your exe and can be used to start breakpoints and running stuff, okay? Also, if we go back to symbols, we can see that it's been imported in it dynamically, so we are set and ready to go, okay? So if I go back to the CPU logic, the first thing you want to ensure is, before I said about the export of a DLL, okay? In this case, we use DLL install and we can see it down the side here. What we want to do is actually go to it and set a breakpoint on, as once we're inside it, we can now look at the APIs and do our breakpoints especially, okay? So, if we go to View and then go to Modules, we'll see a list like we just saw, or you can click on symbols as well, as simple as that. You'll see all the list of here. Your focus is just on the hw.dll or your own DLL from your own malware, okay? What you want to do is, you'll see all the exports listed first, and then the imports, okay? My opinion would be, double-click DLL install, and then set the breakpoint, or whatever the name of your export is, okay? That's really, really important. So, if I refresh this, what we're going to do is then it will take us back into ntdll.dll. So from the Run32 side, we go straight into Hermetic Wizard again, which is fine. We do another one, and we'll see we're now in DLL install like so. Okay. What you guys will see from here is why we're playing the breakpoint here. So the behavior can be observed and single step from the very start. Okay. So if I need to step over functions, I need to step into it. I can do so now freely without anything going awry. If you do not have this in place, guys, your DLL will become much harder to debug and actually understand its behavior. Okay? So, now that that's all done, what we want to do is start setting breakpoints. okay? To do so, I've already set a couple here for it, as we can see here, and they're all enabled. To set breakpoints as a reminder, what you can do is go to Symbols, go to hw.dll, and you want to start searching for certain ones, okay? So if we're looking at propagation, guys, and we're looking at like a worm component, for instance, we want to look at some get-based ones. You want to look for stuff like IPNet table, okay? Or you may want to look for TCP table, okay? So to do so, all you need to do to make sure is double-click it, and it'll take it to the CPU logic directly, okay? What you then do is either right-click and set the breakpoint, or click the dot on the side here, okay? If you see this in place, and then you go to breakpoints and see it's enabled, you're okay to work with it, all right? You'll do that over and over again for each of the ones you need to do. You can set more as you go, and we will see that as we are doing this, okay? However, some of the ones that may be flagged as malicious from your analysis, or you looked at your disassembler and you realized, oh, this is going to be a big problem, you may go, okay, these are the ones I have to start looking at. Let's set a couple, okay? As well, if you want to maybe not look at one, but still be in your list for later on, all you need to do is right click and disable it, and then we'll ignore that breakpoint, okay? Another big one, guys, is you can see that there's a lot, and I mean a lot, especially in this, a lot of different DLLs, okay? Some may be more useful than others in terms of the propagation side exclusively, okay? To determine if one's good or not, go back to your breakpoints. Let's take get IPNet table, okay? We right click, and what we're going to do is edit it, okay? I spoke about conditions back in week 8, if you guys remember. What a simple one you can do is something like caller, brackets, and then hw.dll. What this means is this condition will determine, basically like an if statement, if this DLL, if this API is called by hw.dll, then break. If it's not called by it, and there's something else calling it, then go straight past it, okay? If you feel confident and you want to, or if you're not confident about does this DLL use it, it's a really nice and simple break condition. For your assignment, I don't care about seeing this screenshot here, okay? I don't care about seeing the setup of it. What you may mention is that you may talk about a breakpoint, and that is there significance to you set a condition. You can say you set a condition a condition was set to see if the API is called by the exe or DLL exclusively, and then go into, okay, what does that actually do? Okay, for the sake of argument, this will be called all by Hermetic Wizard directly, okay? So, now what we want to do is go back to CPU, okay? We're actually going to reset again, just so it's nice and clean, and then we jump, or go through DLL install, and then the first one is, we are at get IPNet table, okay? So, with the IPNet table, guys, what you want to focus on is what it actually is. And we spoke about it in the lecture today, okay? What this does is it will retrieve the ARP or the cache of IP addresses and MAC addresses and the interfaces of them, okay? It's not exclusively just IP addresses. That's a big key point, some distinction you need to make, okay? What this particular API, guys, will be in, I think, a lot of your samples, and for a lot of worm-based stuff, it is very common, okay? What it's essentially doing is specifically IPv4 addresses, okay? Version 6 has its own one, okay? And mapping the IP addresses to MAC addresses for all the interfaces, and then essentially what it's doing is it will query and look through this particular table, call it, and then find which hosts are directly available and can be reached via a local link, okay? So what we've already can infer from here, you have to do a bit more digging than just what I'm saying, but you can see that it's been applied, it's searching for stuff, and it's trying to prepare itself for lateral movement, okay? This is a key point. This stuff here is around lateral movement, all right? What we're actually going to focus on, though, is, and what you guys may see is, I could go to the other breakpoint and keep going, but for now, what I'm going to do is, I'm going to F7 my way through this a sec, okay? What we're going to do, And one of the things you do is, yes, you can look for these XORs and any comparisons are being made and so on and so forth, okay? One of the things to maybe save some time and have a quick look at, it's not a perfect foolproof way of doing stuff, is you see in this particular call that there is some more calls to some other API stuff, okay? What we're going to do is we're actually going to set a breakpoint on that API, okay? And then what we're going to do is F7, so we're going to step into it. So this is not always perfect as it goes through over and over, but you guys can see on the side here, for every time I'm doing it, the registers of EX, EBX, and so on and so forth are changing, okay? This may be important for the sake of what is the actual value within them as I'm doing this. Sometimes it's not anything really important, okay? But once we hit this breakpoint here, like so, what's going to happen is we're going to hit it again, and then we're moving into it, okay? We have essentially stepped into this API call specifically, okay? That's a really big important point here, okay? So what we're looking for now is, what is this actually doing? The get IPNet table API is making a call to NSI allocate and get table, but what does that actually mean, okay? It's essentially a routine within the IPHL API DLL, okay? And what you're looking at is the network store interface, okay? It's essentially for storing anything of networking data from across the OS, so it's a big point that's used in conjunction with get IPNet table, okay? So when rather you see it as a get IPNet table exclusively, okay, what it's looking at multiple related APIs, and it's grabbing as much information about a network as possible in preparation to perform the propagation side of it, okay? What you'll see is the essential logic behind it here, but also if you look at the stack box down here, guys, what you'll see is return to and then the get IPNet table, okay? So what will happen is it may step out, and what you can do is essentially control F11 like so, and we can go out of our actual one here like so, okay? It may take a couple points depending on how much is going through, okay? But what we want to look for is the actual enumeration, and if I go back and I'll jump back into it a sec quickly for you all, is if I'm back in this point here, the get IPNet table, I'm actually going to take away this breakpoint here, is we've got the logic here, it makes the calls. Is there any other calls? So for instance, get current thread compartment ID. You may decide, well, that's a bit suspicious. Why is that working in conjunction with get IPNet table? Set a breakpoint there, step over into it, and go on from there. Okay? So also interface, fluid ID, and so on and so forth. So there is a few stuff in here you may look at and go, okay, this is what I need to look for. All right? What may be easier as well, if you guys go into a Gidra or an idle or any other disassembler, you may be able to jump back and forth. Like you see the comparison between EDX and ECX here, it might be easier to see what is actually happening within a disassembler and then come to what happens after the comparison is made, okay? As you can see, it makes a jump and a callback from EBX register to DLL install here. So we're going back in essentially the main function of our DLL, okay? So imagine it's kind of modular. You've got an int main function, you've got a bunch of functions that is our API calls, and the main function is going back and forth between them, okay? You can also see the flags of the conditions like set. So for instance, 1, 1, 0 for all of them, okay? What I want you to focus on now is if we jump a bit forward with the IPNet table, our next breakpoint that I've set is the create file W, okay? This one is very interesting if you look at it from the stack point here, okay? What you'll see is if we're at this point here, you'll see stuff like using certain Windows DLLs here, so you may search up what those are, okay? They may not be having important, all right? But you may see a return to a certain other API calls like so, okay? And what you may see further is, what is that actual file doing if I step further into it, okay? So I go back here, we're actually going to take our point and actually set this breakpoint again, okay? I'm then going to, at this point, just quickly step into stuff, so bear with. Okay, and you'll see the stack start to change and even your memory dump might change as well, guys, okay? So So be careful if you're doing this. If you want to look at every point you can do, this is slow and tedious. I'm doing it for the sake of just ease at the moment, okay? So we go like so, and then we jump into it like so, all right? And then if we want to go further and we want to go to F11, and then go again like so to get to our point, okay? What we can see is we create a file, and then this stack point here, guys, okay? C users, I use a desktop, and then can whe.ocx, and we see it's being created, okay? If I actually go onto my desktop, what may be the case is, depending on when I've run it, I'll run past the breakpoint and we actually might see it be created, okay? What you want to see from the create stuff, guys, is there anything to do with, let's say, creating a certain file? Maybe it's the actual malware itself. Maybe it's a dropper, okay? It really does depend, okay? So what you want to focus on is identifying what exactly is the create file W doing, okay? It does depend on your sample. It does depend on your actual malware, okay? So, I'll go further on from this, all right? If you see this actual point here, this can wait, and there's a bunch of OCX stuff here as well. OCX stuff, maybe some NEXA directly, an obfuscated or encrypted file. This may come up a fair bit, okay? All this is a creation of an OCX file that contains our actual wiper sample, all right? It's running wherever the DLL is being ran itself, okay? That's all this one's doing, okay? And as you can see, there may be not a lot to go on here, so the stack point is a really good point to have a look at. Let's go a bit further, okay? So we set a point, I set a point here, okay, which may look like, what the hell have you done, Joe? Which is, you know what, fair point. But what we're actually going to look at here is, we're looking at, if you can see, ntdll.dll here, we can see RTL wake address like so. If you guys see here, essentially it's getting the value key or any critical section stuff within the actual network itself, okay? Or if I go further like this, IPNet table is called again, allocate stuff, go on from here. What we may be able to see as well is some more OCX being stuff directly into the actual point here, okay? And then you can see DLL unregistered server, all right? You may see this as essentially it detaches itself in the export from a certain server or a certain point. So is this a possible covert mechanism? Depending on your malware, okay? We jump a bit further, like so, we create the file, okay? You can also see, if we look back down in the stack here, from the jump point, return to vbox xrmp, which is for our VirtualBox stuff, return to npr wnet open enum write from somewhere, okay? Essentially, guys, this is to do with, once we create sort of the dropper, we create the dropper, we do our propagation, it drops everything to perform the actual infection side of it. Can it scan and essentially jump through and spread laterally afterwards, okay? So we can keep moving through and we'll see the changes here as well, which you may want to investigate further. If you want to investigate further as well, guys, on, let's say, EBX or ECX, all you need to do is go like that. You can modify a value if you want to, or if you want to have a look at it, you can follow in dump, or follow in dump specifically if it's dump 1, dump 2, okay? Because they're all different points here, all right? So it may be worthwhile, you can do a memory dump to double check, is the file within memory itself here, to have a look. If any of you deal with a lot of obfuscated malware, memory dumps may be your friend to look through. They're not nice to look through, but they may be a solution for you to have a look at, okay? Let's jump a bit more at some propagation stuff, okay? So, we have exception stuff here as well to handle it, but I'll move a bit on further for it, okay? Net server enum stuff, okay? This is another good talking point, okay? What with our enum stuff, if you guys ever see enum, it's enumeration based, okay? So we enumerate over something. We know that, for instance, okay? We may not know what yet, just from looking at this, but we are looking at some form of enumeration, okay? So it's what's known as a discovery API. And what we can do there is enumerate over servers or workstations in the local domain specifically. So in conjunction with that get IPNet table stuff we saw earlier, guys, okay? And highlighting allows you to explain reconnaissance and its low-level features, okay? And deal with raw network configuration, okay? So what you can do is look at the cool API stuff here. So if we go to it, I'm going to step into it like so and actually get into it from this point here, okay? What you may see is a bit more of logic behind set query API set presence and make more calls in the API over and over again, okay? So this is happening inside here, and you can also see, as we saw in the lecture, that netp is UNC computer name valid, okay? So is it a valid computer name that exists within the local domain itself, okay? And then what you may see, guys, is a memory copy or memory set. You may want to set another breakpoint here and actually step into that or step over it if you don't want to actually have a look at it further, okay? Also, you can see down here as well, ZW test alert and stuff like this. So during your malware, there may be cases where conditions are trying to be checked in order for something to occur. For instance, let's say you've got a sample like this. A quick and easy one is, if it's already running and we've already propagated and dropped our file, don't need to propagate any further because we don't want it to mess with the process of the wiper, okay? So if we jump a bit more forward like so, we can see we jump back to something around TCP table, okay? So with the TCP table, guys, it retrieves anything from the IPv4 ARP or neighbor cache and mapping IP addresses to MAC addresses, similar to the get IPNet table, okay? TCP table specifically, what we're actively looking at is roughly around the idea of any TCP connections on the system, including local and remote addresses, okay? And any ports and connection states, okay? Query information to understand what services are currently active, what connections are open, okay? So this will work as well with adapters addresses, so any ports are open. Can it jump through a certain port? Maybe does it need to escape from a local network and go and spread to another network, okay? So TCP table again, what we can do is if we've got, for instance, let's say the breakpoint is, oops, that's the wrong one, like so. We're going to step into it as well. So go quick, all that there. I want to just focus on getting into it, okay? TCP table is called down here. Is there anything to give away? And then call straight back to DLL install, get TCP table, and then the value of TCP table. So essentially, once it grabs all that extra information, the malware knows what to do with it, okay? You may also see around stuff some DNS stuff you may want to have a look at as well, okay? As you can see, it's multiple calls and multiple movement, as you can see. So back and forth. Grabbing the information, does the malware, can it use it? Grabbing it again, just see those constant updates, okay? May even be a loop if it's not dynamically imported. However, a lot of the stuff, as you're seeing here, is dynamically imported. So if you open up in the disassembler, you may not be able to see some certain stuff, okay? So if we go on a bit further, okay? TCP table set, we've got the API stuff set here, okay? Last point I want to talk about here is adapters address, okay? Again, the same point here, we're going to call and break at this point here and jump through here and then actually F7 into it here, okay? What we want to do is maybe search up the disassembler logic of our adapters address. So it's RTL and get a set value key, and it's setting the value of said key as well, okay? What is the logic behind that? Again, you can go down a very, very nasty rabbit hole and go through call, jump, breakpoint, step into it over and over again. I don't recommend it unless you know exactly that it's going to do it, because you'll be in an endless loop, okay? So, one of the big things as well, guys, to focus on as well, and the last point I'm going to mention here, before giving anything else too much away, is any anti-analysis stuff, okay? So if we go back into HWDLL like so, and then if we go into this point here, we want to search for, main one is debugger present, okay? What I want to do at this point here is, you may decide, what is the significance between is the debugger present? So it double checks it, yes. You can even see the comparisons down in here. The difference is, what is it actually checking? Is it checking for a certain feature to not work? Is it checking for the whole thing to not work? Okay, that's something that you may need to have a look at further, because to me, you can screenshot is debugger present, anti-analysis stuff, great, but I want the specifics. It changes from malware to malware, okay? So be aware of that as well, okay? There is a lot more in this. However, I don't want to make this too long and too tedious because I know you guys have got a lot more to focus on, okay? Is it always good to start in a debugger? In my opinion, absolutely not. I personally do not recommend it, okay? What I do recommend is actually looking at it for a disassembler and identifying, do you need a debugger, okay? Don't make more work than you already need to, okay? The last point here, guys, is this OCX file here, okay? This was created, and I spoke about with the create file W API call, okay? What we could do is we could go to P Studio again, open up, let's whack it in there to see if we can find anything here, okay? OCX files you may see is a common type of one that malware uses in terms of droppers from a DLL or any other, even just another exe at some point, okay? So it's a 32-bit executable, okay? We've got the SHA-256 hash here, okay, which is 0385E, which I'll come to in just a sec. What we're going to look for is I want it to go through here and actually look to see what is this about, okay? Now, for context, guys, you can see in file header, compiled Tuesday, December 28th, 2021. If you read on Hermetic Wiper, the wiper itself was created at that time, but launched at a much later stage, i.e. 2022, a day before the Ukrainian war was kicked off. So that's an indication of this might be the wiper. We look at the libraries, okay? lz32.dll, okay? If you guys recall back to my last video, this was the exact same APIs and DLLs I had within the disassembler stuff, all the string stuff as well, like so, okay? So if we look at here, we've got load privilege, we've got a load of empty drive here. This here, guys, this OCX as well, this is the actual wiper being dropped on as an OCX that will then get either unpacked or decrypted to be then launched as a wiper, okay? So if you guys deal with a malware that acts as a dropper as well, you may run the whole DLL, get this to extract, and then analyze this from the get-go, okay? And finally, if we see my downloads from here, if we saw that 0833 here, this application here, this is the one I analyzed in the previous video, and the hash corresponds to what this is. So this, we can confirm that this is the actual Hermetic wiper itself.